This is the first. We've got two worksheets tonight. This is the first one. We're going to walk through this and talk about these together for as long as we have class time, or until I get tired of talking to you, one of the two. Get your notes out. We're writing these down as we're going along. Okay? Get your homework out. We're doing these problems together, but I want to walk through and talk about them. Yeah. The one on the screen right here. So start with A and tell me if it must be true, might be true, or is never true. Suppose f is a function. Somebody tell me what this is telling me. You got to recognize what this is. What is this? And this, keep talking. Say it.
As x approaches 2, the limit is 0.
But more importantly, what is this? Algebra 1. Slope. y2 minus y1 over x2 minus x1. This is slope. In calculus, and the name for slope is derivative. Okay? So, coming back to what you said, Austin, tell me again what this means.
That is, x approaches 2, it's approaching 0.
What is?
The limit.
What is?
The slope.
The slope. This is telling you the slope at 2 is 0. That's what this equation is telling you. If you write that down right there, you can. That means the slope at x equal to 2 is 0. So, look at A.
What's the equation?
There's no equation. You don't need an equation. What is this telling you? Right here.
Slope of 2.
When x is 2, y is 2?
Close. When x is 2, the slope is 2.
Yeah, because that derivative is the slope.
That f prime means derivative. F prime is talking about slope, right? That symbol means slope when x is 2. Is that possible?
No.
So this one would what?
Never true.
Never true. Everybody get that, all right? This symbol means what is the slope when x is 2? Well, it's saying the slope is 2. We already know the slope is 0, so that's not possible. That's false, okay? B.
As a b.
Might be true
Might be true. Tell me why.
because it could.
I'm not saying you're wrong. I'm asking for you to explain.
Could be a straight line down to the y-axis.
Could be a straight line down the slope of 0, right? Slope of 0, so it'd be a vertical line. No, horizontal line, you're right, straight. So horizontal line through the value of 0, sure it could be. Right, it could be just right here. It could be an equation that looks like this. So there's our axis. We want f of 2 to be 0. Since the slope is 0, it could be a straight line. It could be this. That would be fair. Sorry, y'all can't see that.
But either way,
we have,
always gonna be
it's
true.
definitely not always going to be true. It's
Yeah.
possible. We don't know what f of 2 is. Any number of values can be valued for f of 2. We know one fact. What fact do we know?
Slope.
We know
at
slope.
2 is
We
0.
know nothing about the parent function.
So it could be true.
It could be true. So, might be true.
True.
Tell me why.
Because it says limit of x approaches 2 equals f2 is 0.
You don't know f of 2 is 0.
I'm going off the.
You know nothing about f of 2.
Then it might be true.
F2 could be 0.
Who recognizes what this is?
Continuity table.
It's the definition of continuity. You recognize that? This is the definition of continuity. Now, I gave you some notes this week, I think. Now, the last page notes I got you, get them out real quick. What's the title of that last page notes I gave you? The one before that, then, I'm sorry. Differentiability. What is the rules for differentiability at the very top?
Must be continuous.
Must be continuous. Because the derivative is 0, it must be continuous. You would not have a derivative otherwise. Does that make sense to you? If I give you a derivative, that implies continuity at that point. So this must be true. Must be true. Might. Does that make sense? Get your head around that. If you know it's got a derivative, it has to be continuous. Okay?
So this has got to be true as well, right?
Doesn't? Tell me why it might, tell me why it must. Tell me why it might.
We don't know anything about the.
We know whenever x approaches 2, so like e, we know.
Isn't it the whole function continuous with derivative?
No idea.
Yes.
I have no
Not
idea.
necessarily, I mean, we could be.
So for instance, let me give you one that's derivable at 2 and nowhere else. So that's going from 1.5 to 2.5. That's derivable at 2. Had to have a slope of 0, I'm sorry. We didn't read that, I'm sorry. There, now there's a slope of 0 at 2, right? But it doesn't exist over here and here. I know nothing about this point. So this might be true. Does that make sense to you? You can, you know one fact and one fact only about f. There's a slope of 0 when x is 2. That's the only fact about f you know. You cannot make any assumptions about it. And e? E must be true, right? You know that one fact. You know it has a derivative at 2, therefore it must be continuous at 2. We good? All right, look at 44. give you a hint. Before you start answering questions, what do you need to do?
What does that say? A?
You guys are A's.
1, 0, 1. So plug in.
No. Before you do that, what do you do?
You can factor.
You have to factor. Go factor. Don't try to answer these questions until you factor that equation out. You know all the stuff that's going on there, okay? Okay. So once you've factored, then answer your questions. Any thoughts on A?
Yes. So that at A, 0.
Very good. Yes. For some, is F defined? Yes. F of A equals to 0, is that what you said?
Yeah.
Right there. This piece right here tells us that. That is defining the function at a particular point in space, at x equals a, and telling us the y value is 0. Does the limit at a exist? Yes? What is it?
0.
No.
How do you plug in? You
How do you plug anything in?
can't.
Sure you can. How do you plug anything in?
What equals 0 on that?
No.
We have 2 variables.
We got some graph.
But we don't know,
X coordinate of a.
we don't know if that point is gonna fit the.
We have, the only question is, does the limit exist? That's the only question at this point. Does the limit exist? So I have some graph that looks like this. Does the limit exist?
Yes.
What is it? Not A, close.
F of A.
Not F of A. You did your math.
X plus A.
Close. Not X plus A, but
Minus
the limit
Oh, because that's the
as X approaches A of F of X. What's always your first step on a limit? It's always the first thing you do. Plug it in, okay? Plug it in. A plus A, which is 2A. The limit exists and is equal to 2A. That's why I said you need to factor this thing out first, okay? Always factor it out, cross out
2A
your F.
equals 0 then?
We're not there yet.
I'm sorry, I just really don't understand the 2A.
Okay, so if I asked you, so what if I gave you x minus 4 over x minus 2? X squared minus 4 over x minus 2, and I ask you, what is the limit as x approaches 2? That's the question I'm asking you. You factor it out. You cross out, and the last step would be what? You plug that in to tell me the limit is equal to 4. Follow?
Yes.
Okay. That last step, you plug in the A in to the equation you factored out. So limit is 2A. I know nothing about whether 2a is actually 0 or not. I have no way of knowing that. 2a can be any number. We follow me so far? We're going to finish this example out right here. So this is what I've got. 1, 2. And I've got something that looks like this now. Do you agree with that? Is that okay with you? Something that looks like that. Do I know anything about that point?
No.
I know nothing about that point. I know the limit is 4. Okay? 1, 2, 3, 4. I know the limit is 4. I do not know anything about that point. The other half of the expression tells me about that point. Okay? If this says 0 when x equals to 2, then this is the graph I've got. Does that make sense?
Do you have an example on this thing of how it would not be true? How that would be no?
How what would not be true? The limit wouldn't exist?
Yeah. And what would make it not exist? Because anything you plug in is going to give you an answer.
Well, if this had been absolute value of something, for instance, or absolute value
Being
divided.
cross out over.
Yeah. So like if it had been this, if it had been x minus 2, sorry, then the limit wouldn't exist at 2, because you'd have a step function going on right there.
Otherwise,
Okay. So back to this one. Is f continuous at A?
No.
I have a no.
if
I have a don't know.
if 2a equals 0,
Oh.
If 2a equals 0, it would be
we
continuous.
don't know that.
We don't know that.
So I would put maybe.
Okay. This would be only if, or yes, if a equals 0. Because that would shift all of this down right here to where it would match. See, our limit of 2a right here, because the limit was 2a, if a equals 0, then they would match. Because that's the rule, right? In order for it to be continuous, the limit has to match the value of the x coordinate. D is f differentiable at A.
If A is 0. Or
Hmm?
if A is 0. Right?
If A is 0, because it is continuous, right? That's the only time.
What is differential again?
Different means you can find the slope. That would be the only way. If it's any other value, if it's any other value, then we have a hole right there, a removable discontinuity,
So,
and it's not differentiable, okay, or continuous. How are we doing out there? You guys follow me? All right, 4:45. This means something. What's it mean? You can bring your notes. use that if you want
It
to.
means L was continuous.
Does not mean continuous. Before that, it means something before that. It does not mean continuous.
It means there is a limit.
There is a limit. That's what it means. So it's not a graph like this. It's not a graph like this. And it's not a graph like this. It is a graph where the limit exists. That's what it's telling you. That's the only thing it's telling you.
Yeah.
So A,
So it's not continuous. We don't know if it's differentiable.
so A wouldn't, not, it's not true.
It could be.
It could be, but it's
If
not
the
definitely
point
true.
equals the limit.
So on A, you're telling me might be true? What you're saying?
If A,
Is
Not-
A and C not the same thing?
Are we on 445?
Yeah.
I don't see a C.
That is continuous
no.
Those are all the A's.
And this continuous A
That's
is different than.
see,
No,
A
I'm
is
saying-
saying
Oh.
this point.
Right, and these two guys,
A. Yeah.
they may very well be. I'm not there yet. They may very well be the same thing. Let me get there first.
A's.
So is F defined at A?
Not necessarily.
Not necessarily. Could be. Might be. An example of a graph would be this right here. Here's my A. The limit exists. I know nothing about that point. So the limit is L, right? That's the Y value you're approaching. From the left and the right, the limit is L, some number, okay? But I don't know about F of A. I don't know about this one. What is B gonna be?
So it might be.
Might be as well. It could be L,
Could be two.
could not exist at all, right? It could just be a hole in the graph. A and C are not the same image because A is talking about a point on the graph, C is talking about the ability to connect points in the graph. Is it continuous at A?
No, maybe.
Maybe, yeah.
Why are they asking?
They're helping you just get your head around these ideas. You've got these four big ideas out here. You have, does the limit exist? Is it continuous? Is it differentiable? Maybe three big ideas,
Fine.
okay?
That's not a big idea.
Is it differentiable at A?
Maybe.
Maybe, right? We don't know.
To be differentiable has to be continuous, has something else.
It could be continuous.
Has to be continuous, can't have cusps, right?
No cusp.
I could remember.
Yeah. The limit from the left must equal the limit from the right. All right, 446.
We're just trucking along.
We are just trucking along.
She has Jason. Well, we know what the graph should look like.
Do it.
Partly. Maybe like a parabola with a jump.
Okay.
Or missed point. Right?
Maybe.
And it's a starts.
All you know is x coordinates, so you know nothing about y coordinates.
Yeah.
These are x coordinates. So at 1, you're right, at 1 something's happening. Okay? So left of 1 it should be linear.
Should
Right of
it have
1 it should be a quadratic. The
Should it have a
question.
0, 1, maybe? We don't know.
Yeah, you're right. I didn't go through the origin. I should.
Yeah.
I'm sorry. Yeah.
I'm just saying, like, you can tell that.
And the question is, what values of A and B would make it continuous? What values of A and B would make these guys line up and touch each other? Oof.
So we said it,
Set them equal?
Set them equal.
we have three variables.
Yeah, you really only have 2 though, right? One's been given to you.
One is y, no x. be A equals B plus 2?
I believe that's right. Plug your ones in. You get A equals to B plus 2. That is correct. So it doesn't matter what B is. A is going to be 2 bigger. If B is 10, A is 12. If B is 100, A is 102. There's an infinite number of graphs that could be continuous using this piecewise function. And that's okay.
Just says find all choices.
We just did.
That's it, just that?
You just did.
Okay.
Whatever B is, pick a value for B. A is 2 bigger. You just come up with an expression to handle all choices.
And so that's that, that would just be.
That answers question A right there.
Yeah. You get any picks at the bonfire? Mr. Wayne?
Pretty much ignore everything he says. We're thinking I missed an announcement this morning.
He did the county talking in.
Huh?
You know, the
Oh, he gave
extra
like a
5
speech.
minutes, I'm pretty sure it's all because of him talking.
I think he like tries to fill it up so that we don't have extra class.
I don't know. I just pretty much, yeah, when he starts talking, I stop listening, so. All right, so draw the graph of f when a is 1. When a is 1 and x is 1, what happens?
Just a regular.
Is that the point right there? You agree with that?
Betcha.
1, 1?
Correct.
It's going left because it's less than, so 0,
How-
0.
How do we know X is 1 again? Oh, because it has to be less.
Okay. That's what they gave us. Okay.
Alex, calm the head down, so maybe
Do you all agree with that? For the linear part?
correct. It's gonna be a transformation in the second part.
So the second part, we're just going to plug values in, see the fastest to do that. Okay, we plug in 1 in the second part. B is a negative 1, is that correct?
Right.
So negative 1 times 1 is negative 1, plus 1 is 0, plus 1 is 1, so we're right there. Okay.
How are you?
Do we really care?
How are you plugging negative 1 in when it says X is supposed to be greater than 1?
I'm plugging negative 1 for B.
Yes.
Not X.
No,
Not X. Okay. I was like,
So negative 1 times 1 squared. Okay.
oh.
Okay. Plug a 2 in. So negative 1 times 4 is negative 4. Plus 2 is negative 2. Plus 1 is negative 1. Do you agree? Yes or no?
Oh yeah.
Negative 1 times 2 squared, 4. Negative 4. Plus 2 again. Remember that x will be 2 right now, okay? We've already done x of 1, now we're doing x of 2, okay? So negative 4 plus 2 is negative 2, plus 1 is negative 1. So it's down there, and I'm just going to stop right there, something like that, okay? Actually, it's negative and it's going down, so something like that. I really don't want to waste a lot of time
He's
graphing.
making it cuss.
No. It's not cuss.
Alex. You don't know that.
Actually, you do know that.
It is a cuss.
It's absolutely a cuss. One's linear, one's curved.
I told you it's a cuss.
I was freaking right.
For once.
For once. Wouldn't have been wrong.
Maybe one time.
Never.
Got about 2 push-ups, okay? All right, part C. So you did part A, you found the choices where they're continuous. Part C, find where they would be differentiable.
Means you can get a slope.
So anytime it asks you to find values of this where it's differentiable, you have to differentiate the pieces so they're equal to each other. Because there you're talking about slope, right? And once you differentiate it, you've got the slope of the left, slope of the right, so they're equal to each other and solve. So what is the different, if you differentiate a to the x, what do you get?
Here's A.
Just a. Okay. If you differentiate b, what do you get? Or the second one, what do you get?
2x plus 1.
Close.
You get 2b x.
2bx
To be x.
plus 1.
1.
And x bigger than 1. Okay? So now set those equal to figure out a and b to differentiate it. Plug your 1 in. So a equals to 2 plus 2b plus 1. And there's your answer. And we're not going to waste time drawing graphs. Okay?
So that's
So a would have to be equal to
on
2b
values.
plus 1. All values when this is true. Okay? It's going to be differentiable when a equals to 2b plus 1. You okay with that? All right. 447. To figure out the values for continuity, what do you do? You just did it. Set them equal to each other. Solve.
What would you plug in for x? 1.
1. A minus b then. Am I wrong?
What you're doing for A. I just put, you could get 2 equal to A plus B if you want. 3 minus x, so 3 minus 1.
You're right. 3
Two.
minus 1 is 2. Thank you. Sorry. Sorry about that. Okay. Part B says to find where they are continuous and differentiable. What do you have to do on that one?
The derivatives.
You have to derive, don't you? That was A. Part B, you have to derive. Derivative of 3 minus x is?
1.
Nope.
Negative.
Negative 1. There you go. Derivative of ax squared plus bx? 2ax plus b. Plug your 1 in and set negative 1 equals to 2a times 1 plus b. So negative 1 minus b divided by 2 would be a. All right, finish those. There's 2 worksheets. Finish this worksheet, another one up for tomorrow, please, okay? We're going to do, I'll change it out there. We're going to do 40, on this page, we're going to do the odds. I don't know if it says or not, we're going to do the odds on this page, on the bottom there. So I'm going to make sure that, I'm going to do those only on this page, okay? See you guys tomorrow. Got that. Well, I already did one of the worksheets, never mind. We already completed one of the worksheets. This is it right here, so this is it right
So
here.
just odds and odds.
So basically, these four and the odds.
And then odds.
Yeah.
Bye, Coach.
See you, buddy.
Key Club, you are having a meeting in Miss Black's room today.
Hello.
So yesterday I had a lunch detention
Okay.
for an assignment that I had turned in a little bit before they called me down to the office.
Okay, but I
It
should
said-
probably, I probably checked it before I submitted that, so.
Okay. I didn't click submit on it.
Oh,
I
okay.
realized it. And
All right.
Today they gave me another lunch detention.
Not from
for-
me. I didn't.
I know, but they gave me a lunch detention for not going to the lunch detention that I had
Yesterday?
turned in the assignment for.
Okay. That's between you and them. Okay. If they call your name down, you have to go to it. So, but yeah, I submit those things at first period. So if it wasn't their first period, then that's okay. I'm sorry.